Oh, well, so let's just understand the basic key concepts of um, finding where a function is increasing and decreasing. So in this fragment, what we're covering is we're covering the basic key concepts linked up with the properties of the curves. So now assume that there is a function which is graphed like this here. Now I take some critical points. Let's say I take these maximum and minimum points. Now here, these are the points A and B respectively. Now, when you find out the coordinates where there is a stationary slope, there is no slope or tangent is horizontal. As you know that dy by dx is an expression for slope of tangent. So slope of tangent. Now, when the slope of tangent is positive, so if I draw any tangent here, it'll be positive. If I draw any tangent here, its slope will be negative, and here it's positive. So wherever you get to see that the slope of the tangent is positive, uh, just to brief you about when is the slope positive. So any line that makes an acute angle with the positive direction of x-axis, we have these as positive slopes. While if it makes obtuse angle with, let's say, positive direction of x-axis, it is negative slope. Any horizontal line that is here will be having zero slope, and here as well a zero slope. So when you look at the property of the curve here, the property of the curve is changing about this point A and B, and these are referred as stationary point, which I'll cover up a little later. So these are stationary points. Okay, now our next part is to understand uh, where is the curve is increasing, where is it is decreasing. So now where you look at there is a positive slope of the tangent. Now, if I draw a tangent here, it has got a positive slope. If I draw a tangent, let's say in this any point in this region here, so it has got a negative slope. So anywhere where the tangent gets positive slope, that's where it is increasing, and where it is negative slope, that's where it is decreasing. Now, graphically, how do you figure out that there is a increasing point or decreasing point, increasing slope? I mean, the function is increasing or decreasing. So for that context, what we do is we're going to firstly mark the points where the slope of the tangent is zero. Okay, put them on number line as well. So here I put them on number line, and these are my points where the slope is zero because the tangent is going to be horizontal. So at these points, you will have horizontal tangent. Now, in this context here, if you look at the slope of the tangent is positive. So here it is positive slope. Here you can see throughout, if you look at this is like in this range, it is negative slope. Here it is negative. And then if you look at this part, once again, it is positive slope. Now, when you look at here, if they ask you function, where is function is increasing? Now you will, let's say, see where f dash x is positive. If this is strictly increasing, then f dash x is strictly more than zero. Lots of times you get the confusion whether to include equals to sign or not. So this just say if it is increasing, you include. If there is no restriction to, like if they say the word is strictly increasing, then you don't include equals to. Now, if you have f dash x less than zero, less than or equals to zero, then it is called decreasing function. So if it is strictly decreasing, then f dash x will be less than zero. Now remember that f dash x is slope of tangent. Now here the function is basically increasing for x less than or equals to a or x more than or equals to b. And it is also decreasing between a and b. So if the same answer would have been for strictly increasing, it would have been for x less than a or x more than b. And here it would be decreasing strictly between a and b. Now, so this is the key concept linked with the increasing and decreasing function. Now I'm going to take an example for increasing and decreasing function. Like one is numerical example using function, another is already with pre-existing graph. So let's take the first example. So this is the first example where the graph has been given and you are asked to calculate where is it increasing. So as we can see that there are the point around which the slope of the tangent changes are the 2 points, which is x is -1 and x is 2. Here the slope is positive. In this entire range, the slope is negative, and then again slope positive. So you can see that the function is increasing for x less than or equals to -1 and x more than 2. And it is decreasing for where its slope is negative. So that is the blue region here, or you can see from between 1 and 2, -1 and 2. Now let's take an example where the function is given and you want to find out where it is increasing and decreasing. So here's the example about where is the curve increasing and decreasing using the given function. So I'm going to just take the first example and demonstrate where is the curve increasing or decreasing. So first thing what you're going to do is you're going to find out the derivative. Now, before checking about the graph, because you don't have the graph here, you got to find out the derivative. So dy by dx here is -3x squared and plus 6x. So derivative is -6x squared, 3x squared and plus 6x. And you are going to equate this to 0 because you're going to find out, is there any turning point or is there any stationary point where my slope of tangent is 0? So we end up getting 2 points. If I take common here, I end up getting 2 points, which is I get x is 0 or x is 3 as shown here in the answer as well. Now the next step is something called as drawing the Sine diagram. Now you're going to draw the Sine diagram about these 2 points which you got, which is 0 and 2 for the derivative function. So when you draw the Sine diagram, you're going to plug the values. Like for example, let's say if I take 1 here and I can input in this derivative function. If I plug here in derivative function 1, because it is in between 0 and 2, so I get -3 plus 6, which is positive. So 6 minus 3 is coming as positive. So that's why here it is positive. And then you take a value, for example, here, if I take -1 here, something, I get, if I put in here, -3 times -1 squared plus 6 times -1. So that's going to be -3, -6, which is -9. So it's coming overall negative here. So it is negative. Similarly, you can plug here x as, let's say, +3. And if I plug x as +3, so 3 times positive times -3. So overall, it is negative. Now, of course, as we did earlier, you're going to find out the interval where it is increasing. So the function is increasing clearly between 0 and 2, and it is decreasing from 2 onwards and less than 0 onwards towards -infinity. So the exact answer that we expect for this question are basically these. So when you look at the function where it is decreasing, as you saw the Sine diagram, this side it is decreasing here and here, and it is increasing in between. Now you can take the next example as well. Here, first find the derivative, which will be 12x cubed minus 24x squared, equate to 0. You're going to equate to 0. You get x as 0 or x is 2 then. Then you're going to draw the Sine diagram now. So you draw the Sine diagram but for that. So if I draw the Sine diagram about, let's say, 0 and 2, you once again plug, let's say, for example, 3 if I plug. In the derivative, it's positive. And if I plug, let's say, 1, it comes as negative. And here it is positive. So maybe if I take, let's say, -1, it comes positive. Yeah, so here the Sine diagram is positive for this side, which is less than 0 and more than 2. And let's check out the Sine diagram if there is any mistake that I have done in drawing the Sine diagram. So the Sine diagram that we got here is, oh, it's negative, negative, and positive. Yes, that's right. So negative, negative, and positive. What does it mean is that if you see this point here, that's the there is like a turning point. There is a slope, which is like, it's like it becomes flat, and then it further, so it's like decreasing and then further decreasing, and then their slope become positive. So as you can see the graph here, negative slope, but here for a fractional point here, the slope is 0. So that's where it is decreasing for x less than 2 throughout and increasing for x more than 2. So this is how you check whether the function is decreasing or increasing. Now we're going to take one more example about the using the rational function. So to check whether the rational function increases or decreases. All right, so here's one example that is using the rational function. So showing the first part involves the derivative. I assume that you got the quotient rule clarity. So I'm not showing exactly how to find the derivative and show this it is equals to. So what you do is, in this case, let's say I'm assuming that the derivative of 2x minus 3 is x squared plus 2x minus 3 of x squared minus this fraction is equals to, if you apply quotient rule, you're going to get this. So x minus 1 square, x plus 3 the whole square, and negative 2x and x minus 3. So derivative part you can look at or work out, or in this later on, I'm going to show the answer. So you can check from there. Now, the first thing that they ask you is to find out the intervals where it is increasing or decreasing. Now, since it is a rational function, our sign diagram criterions become very important here. So you're going to take the roots of numerator, which are 0 and 3. So the roots of numerator are 0 and 3. And the roots of denominator, which are here, are 1 and negative 3. So there is going to be a vertical asymptote at 1. So you're going to take vertical asymptote at 1 and vertical asymptote at negative 3. So when you take these vertical asymptotes, you got to be very careful about placing the numbers. Like, don't put 0 here and then minus 3 here, because all the signs are going to go wrong. I'm going to take one value from each part. So let's say I take positive 4. If I take positive 4, positive, 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 but because it is becoming negative. So here it is going to be negative overall. Then here I can take, let's say 2. So if I take 2 minus 3, it's negative. Negative times positive 2 is negative. And then again negatives, but this become positive here. And of course, denominator is always positive. You can see square terms. So here, overall, it is positive. Now let's take, here you can take 0.5. So 0.5 minus 3 is negative. Negative times positive is, it's going to be negative. Negative times negative is positive. So here, once again, the slope is positive. Then you can take, let's say, negative 2 here, and you will notice that the slope is negative. And then if I take here negative 4, if I put negative 4 times negative 2 is positive, then positive times negative, once again, here it is negative. So the sign diagram that you get is negative, positive, positive, negative, negative. So you can see that the function is decreasing for x more than or equals to 3, or x less than or equals to 0, but x should not be negative 3. Because at negative 3, the function is undefined. And here, if I take x more than more than 0 or x less than 3, but x should not be 1 for it to be increasing function. And for decreasing, it is in this interval. So let's just cross-check our answers with the pre-existing answers given in the textbook. So we can just cross-check our sign diagram. All right, so sign diagram is pretty much the same. Yeah, here we go. Yeah, sign diagram is the same. So it's negative, negative, positive, positive, and then again negative. So this is how you check and do the questions based on the increasing and decreasing functions. And in case if you didn't understand how to find out the derivative of this question, here is the working for that. And you can use this for your better understanding.